Exercise set B question 1. This question is about discrete time martingale. There are 2 points to note in this question apart from getting some practice with this martingale property. Is that the first is in textbook there is this property is shown like this, and they say, for example, if a random process has this property, it is going to be a martingale. Anyhow, for discrete time, there is this property holds that if we can show this property holds for only a single step or single time ahead, then we can infer that this property holds for every time, and as a result, it's going to be a martingale. So here is a note about this property. Other point that it's worth noting in this problem is to get familiarity or get used to using both notation for the conditional expectation. As you see, this notation uses some sort of index and show that the expected value of this random variable at time t. So going to the solution, we need to start from this given property to reach to this property. Okay, now going to the solution. Here we note that if we have some relationship for time t, and when it is stated it holds for any time, so we can simply change the index accordingly and get or adapt that definition or relationship for any time that we like. So here we can say st plus 1 is equal to the expected value of st plus 2 given the information set as omega t plus 1. It doesn't have to be only t plus 1. We can state this relationship for st plus, for example, whatever number 10 is equal st plus 10 plus 1, which is st plus 11, given the information set at time 10. Anyhow, starting from the given statement, we try to infer the required or desired relationship. So this is the given of the problem. If we replace st plus 1 with its equal or equivalent value, here we get this relationship. If you see in the lecture slide or in your book, there is a property for this conditional expectation that, if I want to say informally, is that if we have an expected value of some random variable given some big information set, this is the big information set. Again, if we take an expected value of this expectation given some smaller information set, mathematically it means this information should be a subset of the big information set. So then this property holds that it will be equal to this expression. That is, we can simply bring out st or whatever random variable here is out of the expectation. Okay, so here we did the first step. We started from this relationship and we ended up with this relationship. That is, st is equal st plus 2 given information set at time t. Be very careful about this index of the information set. These indexes are important. Anyhow, so there is nothing to keep us that we do not repeat this procedure. Now we can replace st plus 2 with its, here we replaced st plus 1 with its equivalent or equal relationship in terms of expected value. Here we can replace st plus 2 with its equivalent relationship based on the expectation. If we do this procedure for whatever time that is necessary, at some time we can say, okay, this is st plus h, which will be equal to st at time t. So this is the way to do this exercise. Anyhow, here, if you get used to at some point with this alternative notation, you see that things are a little bit neater, although conceptually and everything is the same. Things are sort of neater, and in a cleaner way we can reach this same conclusion. And this is more friendly, at least to my eyes, that I see if there is some lower t here and a bigger t here. So I can simply say that this random variable can come out of this expectation, and I have this relationship. Again, repeating this procedure, here we can reach to the desired statement that is asked in the question. This is the end of question 1.